this is Mrs. Peck showing you how to fill in page 6 of your notes for Unit 12. There are three main types of radioactive radiation: alpha, beta, and gamma. And one of the way how they were found and how we distinguish between them is by their charge. So go ahead, have a look at that. You have the drawing neither in your notes, but ultimately you have a radioactive source surrounded by a lead block that makes sure the radioactive radiation only goes one way. You have a positive plate on one side, in our case on top, a negative plate on the other side, in our case on the bottom, and the different radiations respond differently to those plates. So if you think about how they respond to those plates, please identify the three types of radiation as either alpha, beta, and or gamma. Go ahead, pause the video for a moment. I hope you found these answers as opposites attract. So beta is a negative radiation, so it's attracted to the positive place. Vice versa for the alpha radiation, and the gamma radiation with no charge is attracted to nothing. Okay. Now this chart is summarizing the information that you had on the last 2 pages. So as you read through that, you realize that alpha radiation happens in nuclei that are simply too large, that have too much of everything, protons and neutrons. Beta minus decay takes place in nuclei that have too many neutrons. And beta plus happens when there are too few neutrons, or not enough neutrons. In an alpha decay, the atomic number goes down by 2 because you're losing a particle with an atomic number 2. Mass number goes down by 4. The beta minus changes the atomic number, that it increases it by 1. Mass doesn't change. And for the beta plus, it's the other way around. Gamma radiation is not really a type of decay. It just happens with all of the others. So it accommodates all the types of decay. And it does not change mass